Hello, everyone. Myself, R. Murali Mohan, Assistant Professor, Government Engineering College, Ramnagar. I'm talking on mechanical measurements and metrology. Subject code 18ME36B belongs to third semester BE Mechanical Engineering, particularly Module 5, Applied Mechanical Measurements. Today, session 1. First, we'll see what exactly a force in your earlier classes. You might have studied definition of a force. Once again, we'll rebrush. A force is defined as the reaction between two bodies. The reaction may be in the form of a tensile force, that is a pull, or it may be a compressive force, that is a push. A force is represented mathematically as a vector and as a point of application. Moreover, the measurement of force, which involves the determination of its magnitude as well its direction. And the measurement of the force may be done by two different ways, namely direct method and indirect method. In case of direct method, a direct comparison with a known gravitational force on a standard mass. Best example for this is a physical balance. See, if we consider a body of mass m in the Earth's gravitational field experiences a force F, then mathematically we can write force F is equal to m into A, where the m into A put together we can write W. W is the weight of the body. A, small a, is the acceleration due to gravity. Any unknown force may be compared with the gravitational force on the standard mass. See, then the value of mass and acceleration due to gravity should be known accurately in order to know the magnitude of a gravitational force. Now, look into an indirect method. This method, which involves the measurement of the effect of force on a body. Best example for this is measurement of acceleration of a body of known mass with a which is subjected to a force. And in a another way, I can give one more example. The force is applied to an elastic member is also a best example for indirect method. Analytical balance. So this is an direct comparison method for unknown force with a gravitational force can be determined. See, the analytical balance is also called as an equal arm balance. See, look into the sketch. It consists of a balance arm, right? And it has a scale. And the direction of a force, which is parallel to that of a gravitational force, and hence only its magnitude need to be determined. Analytical balance is moreover has an balance arm, rotates about point O, and two forces, namely W1 and W2, are applied on either ends of the balance arm. Either ends of the balance arm onto the left extreme and onto the right extreme, namely W1 and W2. W1 is an unknown force. W2 is a known force due to a standard mass, where capital G is the center of gravity of the balance arm. Unbalance is indicated by an angle theta. See this, you can look into here, which the pointer makes with vertical. So in the balanced position of an analytical balance, if W1 is equal to W2, hence theta becomes 0. So see this whatever theta and W which is defined by a term called as a sensitivity, that is sensitivity represented by S of an balance is S is equal to theta divided by delta W, it is, that is W1 minus W2. The sensitivity can be calculated by writing the momentum equation at equilibrium condition. You are well known in your engineering mechanics classes. You know how to resolve the momentum of equation under equilibrium condition, right? Now, so with respect to point O under equilibrium condition, W1 L cos theta minus dB. See here, dB sin theta is equal to W2 L cos theta plus dB sin theta plus WB dg sin theta. See where distances dB and as well as dg and L are shown very clearly in the figure. For a small deflection, we need to make certain consideration. We will substitute sin theta is equal to theta and cos theta is equal to 1. See in this above equation, when we substitute it, we will get it W1 into L minus dB theta. See here, you can substitute back here, instead of cos theta you can substitute 1, L into 1 is L minus dB. Instead of sin theta I can substitute theta. Now dB theta is equal to W2 L cos theta, that is instead of cos theta 1, that is L, plus dB sin theta, instead of sin theta I'll substitute theta, plus WB dg sin theta. Now it becomes WB dg theta. See now the sensitivity S is equal to theta by W1 minus W2. When I simplify it, L divided by W1 plus W2 dB plus dg WB. See, when I say an equilibrium, right, then W1 is equal to W2 is equal to W. Hence, sensitivity S is equal to L divided by WB into dg. So, sensitivity S is equal to theta divided by delta W, that is equal to L divided by 2 W dB plus WB dg. So the sensitivity of the analytical balance will be independent of the weight W, provided it is designed such that dB is equal to 0. Then this equation becomes sensitivity S is equal to L divided by, right now this whatever term, this first term 2W dB becomes 0, then the remaining term is what? WB dg. Therefore, sensitivity S is equal to L divided by WB dg. See now, second force measuring device and an unequal arm balance. See in an certain drawbacks which encountered in equal arm balance. See that has to be rectified by using an unequal arm balance. See here we are using some sort of lighter weights, and you can analyze the force which is measured by an instrument. See here, an unequal arm has two arms. First one load arm onto the left extreme end with respect to the pivot. Onto the right hand side with respect to the pivot arm there will be a power arm. See the load arm which is associated with the load, right, that is the weight force to be measured, while the power arm is associated with the power, right, that is the force produced by counterposing weight, counterposing weights required, right, to set the balance under equilibrium condition. Now if we consider a mass of m, which acts as power on the beam and exerts a force of Fg due to gravity, then we can say Fg is equal to m into j is a fundamental equation. This force which acts as a counterposing force against the load, which may be a test force Ft, and to balance of moments, right, Ft into A is equal to Fg into B. This is the Ft, right, and here see this is the Ft and this is Fg here, right. This is the test force and this is Fg. Okay, now Ft is equal to, see when I interchange, see from this equation when I interchange, right, the terms Fg into B by A, right, I send it A to the denominator, then instead of Fg I can write m into g, right, into B by A. CFT is equal to again constant into B, where G is a constant. So when I substitute M is equal to 1, then I can say Ft is equal to constant into B. Therefore, the test force Ft is proportional to the distance B, right? That is the distance B with respect to the power arm, right? To of the mass from the pivot. Say if a mass m is a constant and the test force is applied at a fixed distance from with respect to the A, right, with respect to the knife edge, see this is the knife edge. Now the right hand of the beam may be calibrated in terms of a Ft now, right. See this particular instrument or a machine can also be used for the measurement of unknown mass. Suppose the force Ft, that is a test force Ft, is produced by an unknown mass m1, then Ft is equal to mt into g, and still I can simplify it, m1 into g into A is equal to m into g into b it is, or I can write m1 is equal to m into b by A, that is equal to a constant into b from the earlier equation. The power arm B, maybe this is the B, right, can be calibrated to read the unknown mass m1 directly. Now we'll see how exactly a platform balance which has been utilized to measure the force. Say in an equal arm balance and an unequal arm balances which are not suitable for measurement of large weights. So to overcome this difficulty, say an platform balance which has been recommended, and when measurement of large weights which have been involved, then definitely multiple lever system, right, shown in the figure has been used. In this system, a large weight W is measured in terms of two smaller weights, WP and WG it is. WP and WG it is, where WP is equal to poise weight and WS is the weight of a pan. Okay. Now the system is provided with an adjustable counter poise. Adjustable, this counter poise what we have, right, which is used to get an initial balance. See, before the unknown load W is applied to the platform, then the poise weight WP has to be set to 0, right. Say now the beam scale and this is the beam scale and the counter piece is adjusted to obtain initial 0 balance. It is assumed that the weight W, right, can be replaced by two arbitrary weights W1 and W2. Then with the help of the momentum equation, T into W is equal to Ws into A, where T into C, right, T into C, you can look into this, T into C is equal to W1 into F divided by D into E plus W to H. This I'll call it as equation 2. If the links are so proportioned that H by E and F by D, ratios of H by E is equal to F by D, then we can get it this T by T into C is equal to H into W1 plus W2. Then W1 plus W2 put together, I'll write it as a W. Then HW, I'll say this is equation 3. See, now it can be eliminated from the equation 1 and 3 to get WS A by B is equal to WH by D, where unknown weight W, right, can be represented in the ratio of A by B into C by H into WS, where M is equal to the ratio of A by B into C by H, which is called as a multiplication ratio or a factor, we say, right, for the scale. It is indicated of weight that should be put in the pan to balance the weight on the platform. Now see, if I say the beam scale which is divided that moment of a poise weight WP by one scale division, which can be represent a force of certain kg, right, with a poise moment of y direction scale division, that should be produces the same result as that of WP, that is weight of the pan placed on the pan at the end of the beam. Then WP into y is equal to x y a it is. Then I can see, I can cancel both sides onto the left hand side and right hand side, so y term. Then x is equal to WP by a. See, this particular equation, that is x is equal to WP by a, represents the relationship that determines the required scale division on the beam for any poise weight WP. Now we will see certain multiple choice questions for the session. The following method of measurement of force involves a direct comparison with a known gravitational force on a standard mass. See, the options are direct method, indirect method, experimental method, all the above. See for direct method, always it's a measurement of a force. It involves direct comparison with a known gravitational force on a standard mass. Then definitely this is the first method, that is a direct method of force measurement. Answer will be A. Next question number 2. Direct comparison of an unknown force with the gravitational force can be explained with the help of an. Options are A. Unequal arm balance, B. Analytical balance, C. Platform balance, D. None of this. See here, see, direct comparison of an unknown force with a gravitational force can be explained with an help of. See, then definitely, right, it would be an analytical balance. Third question, when a measurement of large weights is involved, dash is used. See, options are a platform balance system, multiple lever system. See, a platform balance system can be used whenever you have smaller weights which have been involved. When want to measure larger weights which are involved, then definitely multiple lever system which has been used. The answer is B. Fourth question, the unequal arm balance uses the following two arms. Options are A. Two load arms, B. Load arm and power arm, option C. Two power arms, option D. None of this. See, in an unequal arm balance uses two arms, namely what? Load arm and power arm. One load arm and one power arm, right? Answer will be a load arm and a power arm. The fifth question. Measurement of acceleration of a body of known mass which is subjected to force. The following statement is false or true. See, options false or true. See, is definitely, see, from the acceleration measurement of acceleration of a body of a known mass which is subjected to force, the statement is true. It is F is equal to m into a, right? The sensitivity S of the equal arm balance is expressed by, see, certain equations have been given here. Options A, S is equal to W by A, B is equal to S, B, S is equal to W1 minus W2 by theta, S is equal to theta divided by W1 minus W2, D is equal to S, sorry, D, option D, S is equal to W2 minus W1 by theta. See here, your well-known sensitivity of an equilibrium balance is equal to generally theta divided by delta W. Then this is not the answer, and this is not also the answer. Then definitely, then there will be answer will be what? Theta divided by W1 minus W2, right? That is, sometimes they might have given delta W also. That would all be right. Seventh question. The poise weight is used in a dash type of balance. Options are equal arm, unequal arm, multiple lever arm, single lever. A poise weight which is used, that is a WP, which is used in a multiple lever arm. Multiple lever arm type balance system. The power arm in unequal arm balance may be calibrated to read the dash mass directly. So options are A, standard, B, unknown, sorry, known, C, unknown, D, gravity. See, then definitely an unknown mass is definitely calibrated to read, isn't it? See, then the option is C, unknown. Multiplication ratio is used in a dash type of balance. Options are equal arm, unequal arm, multiple lever arm, single lever. Option is C, that is multiple lever arm. Multiplication ratio or a factor m it is, right? The force is applied to an elastic member is an example for measurement of force by the following statement. Option is A, direct method, B, indirect method. See, when the force is applied to an elastic member, right, is a best example for indirect method of measurement of force. Option is B, it is.